Alright, so the last part of 7.3 is to use a calculator to find the confidence interval for the mean, and I'm also going to show you how to do it for the population proportion, which is from 7.2. So here are the steps, and I'll show you how to enter these steps. If you want, you can take a few minutes to copy them down or rewrite them on your notes if you need to. Okay, so let's say that we want to measure the miles per gallon that cars at El Camino College, or the average mile per gallon for all cars at El Camino College. So what we did is we took 10 cars randomly and we measure, or we determine their mile per gallon. So we're gonna construct a 95% confidence interval for the average fuel consumption of all the vehicles at El Camino College. We're going to do this using a calculator now. So that's talking about population mean. Okay, we're measuring the population mean of these data. We're going to go ahead and enter these data into a calculator. So first, if needed, enter the data into the calculator. So that's what I'm going to do first. So stat, and then choose option 1 to edit the list, like that. And then I'm going to clear this list and I'm going to enter these data into the list. So we're looking at 15.8, 13.6, 15.6, 19.1, 22.4, 15.6, 22.5, 17.2, 19.4, 22.6. So those are the data for 10 cars, right? So once I've done that, I'm going to click on Stat Tests, and I'm going to choose Z interval if I know the population standard deviation, but I choose T interval if I don't know the population standard deviation. In our case, I don't know the population standard deviation, so I'm going to choose T interval. Okay. So again, I don't know my population standard deviation. I don't know it, so I'm going to choose T interval. So stat, tests, T interval, option 8, and then I'm using data, and I'm using data from list 1, and it's going to ask you for a confidence level. We want to be 95% confident, so we chose 95%, and you can change that number. Slide down to calculate, hit enter, and it does the work for you. And look what it says, you're done, see? So look what it says, the 95% confidence interval is between 16 to 20. Okay, so I'm going to copy that down. So it's 16.009 to 20.751. Okay, so what does that mean? We are 95% confident that the average fuel consumption for each car at El Camino is between 16 miles to 20 miles to approximately 21 miles per gallon. Okay, there you go. Nice, quick, and simple. All right. And again, you can do the same thing if you're looking for the confidence interval for your population proportion. Let me kind of go back and maybe find the confidence interval for this example using our calculator. So notice that I don't have data. This is what we call data. Okay, this is what we call data. I don't have data. I have what we call statistics. So these are statistics. This is the sample size. Okay, so that's what I have. I have statistic. So to calculate the confidence interval, click Stat, slide over to Tests, and because I know my population standard deviation, I choose Z interval. Okay. Now my input is not going to be data because I don't have data. I have statistics, so I choose statistic. And then you enter your known standard deviation, which is 100. X bar, which they give us to be 50. We're testing 50 light bulbs, and we're setting it at 95% confidence, which is there for you. And you just hit calculate, and voila, look what that. It's about 32, see? 322 to 377. So very similar to the number that we got. Alright, look, there you go, see? A little off, but very pretty close. Okay, good. Alright, the last thing we do is how to find the sample size to achieve a specific accuracy. Remember that the higher the sample size, the more accurate your estimate is to the true value of the population. The sample size is found by taking the Z times sigma over E and then squaring it. Okay? Let's take a look at an example on how we use that formula. Let's say a college president asks the statistic teachers to estimate the average age of students at the college. The statistic teachers would like to be pretty confident, 99% confident, that the estimate should be accurate within a year. So they don't want to be off by more than a year. That's what we mean by accurate within a year. So let's summarize what we have so far. So 99% confident, and our accurate within a year, which means that our error is 1. Okay. Now remember, 99% confident means that we use that data to find the Z value because that's our critical value. So at 99% confident, you can see that the Z value, the critical value, is 2.575. Okay. And then sigma, which is the standard deviation, is known to be 3. So we know that's 3. And all we have to do now is plug it into that formula. So sample size is going to be 2.575 times 3 over 1 square. Okay. So let's do the math and see what we get. So we're looking at 2.575 times 3, and I'm going to square that. So I'm looking at about, I square that, I'm looking at about 5960 people. So 59.6. So now we answer the question. The sample size should be at least 60 people in order to achieve an accuracy of student age within 1 year. There you go.